said that perimeter is equal to 2 L's plus 2 W's. So what does that mean?
It's just a shortcut for rounding up all the sides and all the...
2 L's and two widths, 2 lengths and 2 widths. But you said it's a shortcut for doing what?
For just adding up like 4 plus 4 plus 5 plus 4. 6, yeah.
So 6 plus 4 plus 6 plus 4. In other words, length plus width plus length plus width.
Yeah.
And that's the same thing. Okay, did anybody think of it a different way than either of these? This is just starting and going around, right? This one's recognizing that the 2 lengths are the same size, so let's use a little multiplication and shortcut it. How many operations did we need to do this one? 1, 2, 3, right? 1, 2, 3. I guess it's about even. 3 different operations. Anybody think of another way of doing it? Yeah.
Count them one by one. They'll become long.
So just individually count the squares going around, rather than adding up the sides. That's a, yeah. So we would add up the individual numbers in the length, plus the individual numbers in it, so that's even getting more fine-grained. Okay, anybody else think of another way of looking at it? Yes?
Length plus width equals 2x. You get what I'm saying?
No.
So
Maybe.
6 plus 4 equals 10 times by 2 would be 20.
Oh. So she's taking it like this and saying, I'm going to erase kind of the, take the width plus the length, or length plus the width, and that would be how long this is, but this one's the same, so we times it by 2. Is that the same as these?
Yes.
But it's what?
When it's distributed.
Oh, so if I went like that and that, what would I get? This, right? Okay, but it is a different way of thinking about it, definitely. Anybody else see a different way to find the perimeter? We've got, including the one we had back there, I just can't put that into a formula because we don't know how long a general one is. Perimeter tells distance, right? Now what I'd like to do is you've built your fence, and guess what? You came out there one morning, and your dog was gone. And you notice that he has dug underneath the fence. You made the fence high enough. And you think, first I got to go find him. You find him at about 3 neighbors' houses away. Drag him back home, but before you put him in, you're not going to, you know you've got to what? Fix the problem. So you go and get some plywood. Some plywood. You just buy some thin plywood, and you're going to put plywood down on the entire floor of the doghouse. I need to know how much we got to go buy. Okay, so go ahead and now you can use your tiles as covering instead of fences if you want. How much plywood are we going to need? Area. So what did you get? 24. How did you get 24? Let's hear your methods.
6 times 4.
All right.
I just went through instead of fussing the lengths and the width, we just timed them. We've got 4 on the bottom and 6
So
at the
length times width. Did anybody think about it differently? So what you're saying is it took 6 tiles to cover 1 row, and there were 4 rows. So 4 times 6. Anybody think about it differently or do it differently? Yeah.
You could just, it's just a long way, like you have 6, so you could add 6 together 4 times, or 4
So you
together
could
6
say,
times.
length plus length, and do that
However many times.
with number of times. Because in this case it's 4, but it might be something different. Right? Everybody understand what that? Do it W number of times. W. Okay, anybody else have a different way? Did anybody just go like this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That's kind of like you were talking about before. And that's going to be hard to put into a formula, right? A general formula. But, all right. I'm going to put a box around this one because the formula for the area of a rectangle is going to become what we're going to call our mother formula, the mother of all formulas. Why are we going to call it a mother formula? Because just like we call Eve the mother, every one of us came through Eve, right? And every one of our formulas is going to come from the rectangle formula. That's why we're calling it the mother formula. Every formula that we get is going to come back in some way, directly or indirectly, to the rectangle formula. Okay. So here's the rule. What is this figure, by the way? Parallelogram. So what I want you to do, here's the rules. You can cut out, you can cut it up, rearrange it, you can duplicate it, meaning you can make another copy exactly like this one, and put your duplicates together in a form, but your goal is to somehow go back to the rectangle. I'm going to put, this is how I'm going to do it right here. The perimeter, can everybody see the little figure here? Perimeter of a rectangle, area of a rectangle, okay? Of this rectangle? No. In fact, does B even play into this? No. So all we want to do is we want to take this length, which was the length of our, okay, and times it by the, what do we call that? Height. What would the height of a parallelogram be defined as?
The perpendicular, like, altitude between the parallel lines.
Okay, perpendicular altitude between the parallel lines. It is perpendicular to both of the bases. And so, can everyone see that if we take what we call the base of the parallelogram and the height to that base, which is the perpendicular distance to the other base, we end up with, here's our new formula for the parallelogram. We're going to go base times height. In this case, A is the base and C is the height. Does that make sense? But we can take it back to mama, right? By cutting one off, putting it over here.